This video, as you can tell, is about the real number system. First off, basically numbers fit into different categories or sets. The first set is natural numbers, and that's numbers such as 1, 2, 3 and so on. And the abbreviation for that set is N for natural numbers. The next set is whole numbers, and that's basically natural numbers plus the 0, so 0, 1, 2, 3 and so on. And this, as you might expect, is a capital W is the symbol for that set. The next set after that is integers. What that does is it adds the minus numbers on. So minus 3, minus 2, minus 1, 0, 1, 2 and so on and so forth. And just to catch you out, the symbol for this one is usually a Z, which the reason it's Z is because it comes from a German word. Right, and all these different sets make up what is known as rational numbers. And the symbol for that lot is the letter Q. Again, that's because it comes from a German word. So if we have rational numbers, then it only seems sensible to have irrational numbers as well. And the symbol for that is a Q with a bar over the top. So what's the big difference between rational numbers and irrational numbers? The basic rule is if you can express a number as a fraction, then it is a rational number. If a decimal has a pattern, 1.2122121, there's a pattern, therefore it's a rational number. Irrational numbers, basically you can't write them as a fraction, and the decimals do not end and do not have a pattern. Examples of these are pi, which has been calculated out to I think almost 1 million figures, 1 million digits, and there's still no pattern to it. Another couple of examples: the square root of 2, square root of 3. If you write those out in decimals, there's no pattern to it whatsoever, so those are irrational numbers. And, I'll just do a bit of erasing. In fact, I'll just do this. One thing you might have noticed is numbers can belong to multiple sets. So let's say 7 over 2, it's a fraction, therefore it is a rational number, but it doesn't belong into any other sets. If I use the number minus 2, it's both a rational number and an integer. If I use 0, it's a rational number, an integer and a whole number. And then if I do 2, it's a rational number, an integer, a whole number and also a natural number. Right. The next bit I want to talk about is estimating a value for a square root or a cube root. One really useful thing to know off by heart, not just for this but as you go into other things, is to know the first 10 perfect squares and perfect cubes. So there's the tens, and the square root of 1 is 1, square root of 2 is 4, square root of 3, so square of 3 is 9, square of 4 is 16, 4, 81, 100. And then the cubes of these numbers are 1, 8, 27, 64, 125, 216, 343, 512, 729 and 1000. That's useful for basically if we're given a square root, guessing or approximating where it is on the number line. So if I have the square root of 11, I can just look up here and go, oh, 11 falls between 3 and 4, and it's a bit closer to 3. So I know the number falls somewhere between 3 and 4, yeah, but it's a bit closer to 3. So what I'll do is I'll guess at, let's say I'll guess at 3.3. And 3.3 squared is 10.9. 3.4 squared is 11.6. So I know it's approximately 3.3. Let's do a slightly bigger one. Square root of 55. Looking up here, 55 is between 7 and 8. A lot closer to 7 though. So let's go with, let's say 7.3 squared is 53.3. 7.4 squared, looked it up on the calculator, is 54.8. So I'm not going to get any closer than that one. So now let's do a couple of cubes and see how those work. And if I do cube roots, let's find the cube root of 88 next to the 3 at the front there. Looking at 88, that's between 4 and 5, and it looks to me like it's it's probably just on the 4 side of halfway. So I'll go with 4.4 cubed is 85. 4.5 cubed is 91.1. So that one is 4.4 is just a little bit closer. Let's try a bigger one. 400, the cube root of 400. Looking up here, that's between 7 and 8, and it's a lot closer to the 7. So I'll guess at 7.4 cubed, and that comes out at 405. And that's all there is to it.